All right, so in our last video, we focused mainly on factoring out greatest common factors from polynomial expressions. Now what we're going to do is we're going to connect that idea with the idea from the video before that, which was the zero product property for solving polynomial equations. So what I'm going to do right now is go through 3 examples with you, and then we're going to go to the next slide. There's going to be a couple examples that you're going to try on your own. So I'll have you pause the video and try those on your own. Then I'll solve those, show you how to solve those again. And then we're going to talk about finding the zeros of the function and how that's pretty much the same exact process, but just has a little bit different meaning than just strictly solving polynomial equations. So let's take a look at the first 3 examples. And there's some instructions here for you, or some tips that you can try when you're solving a polynomial equation that's not in factored form. So the first thing you want to do is move all the terms to one side of the equation, essentially setting your polynomial expression equal to 0. And I'm going to jot that down right here off to the side. So you want to set polynomial expression equal to 0. And this is so we can apply the zero product property that we learned about a couple videos ago. Then the second thing is factor out the greatest common factor. And then 3, as I just said a second ago, apply the zero product property. So let's go ahead and take a look at problem number 1. So again, I focus first on the coefficients. So here, actually, I should take a step back. In this case, all the terms are on one side, so the polynomial expression is set equal to 0. So now we can move on to factoring out the greatest common factor. So let's go ahead and do that. So if we look at the numerical coefficients, the greatest common factor shared by 18 and 9 is 9. And the greatest common factor shared by the variables, in this case p, is p. So 9p squared divided by 9p is just p. And then positive 18p divided by 9p is positive 2. So there we factored out the greatest common factor. And now let's apply the zero product property. So I'm going to set each of these factors equal to 0. So I don't know why I put a 2 there. 9p equals 0, and then p, I should write or p plus 2 equals 0. All right, so on the left-hand equation, we're going to divide both sides by 9. And one of our solutions to this equation would be p equals 0. Or if we subtract 2 from both sides, we're going to get p equals negative 2. So p equals negative 2 is another solution. So these are the 2 solutions to that equation. Again, I would encourage you to go back and plug those answers back in to check your solutions. In this case, again, I've done that already, and those do work. So let's check example number 2, or try example number 2. So we have 48x squared equals 32x. So this is one of the problems where we're going to have to move all the terms to one side of the equation. So since the coefficient of x squared is positive, I'm going to subtract 32x from both sides. And that's going to give us the equation 48x squared minus 32x is equal to 0. So now this equation, so problem number 2, looks a lot like the equation that we had in problem number 1, where the polynomial expression is set equal to 0. So now again, we're going to start factoring. Greatest common factor of 48 and 32 is 16. So both of those numbers are divisible by 16. X squared and x, common factor would be x. So 48 x squared, rather, divided by 16x is 3x. And then negative 32x divided by 16x is negative 2. So again, now we're at a point where we can apply the zero product property. So we're going to take each factor and set them equal to 0. So divide both sides by 16, and we get x equals 0 for one of those answers. And then on the right-hand side, we're going to add 2 to get 3x equals 2, and then divide both sides by 3 to get x equals 2/3. So again, you want to check your answers by plugging those back into the original, making sure they're correct. I have done that And those answers are indeed correct. All right, finally, our third example. So we've got 15x equals negative 2x squared. Things tend to work out a little bit nicer if the leading coefficient or the coefficient of your term with the highest degree is positive. So what I'm going to do here is I'm going to add 2x squared to both sides, just so my leading coefficient is positive. So it's going to give me 2x squared plus 15x equals 0. All right, so we've taken our polynomial expression, set that equal to 0. Now what we're going to do is factor out the GCF. So in this case, it's just going to be x because 2 and 15 don't share any factors. 2x squared divided by x is 2x. 15x divided by x is positive 15. That's going to equal 0. So as we have done in the previous examples, we're going to take each factor and set them equal to 0 and solve those equations. X equals 0 is all set. That one solved completely. The second one, however, we'd have to subtract 15, so that's going to give us 2x equals negative 15. And then divide both sides by 2. X is going to equal negative 15 over 2. So these would be the solutions to our equations. You could take a decimal approximation of that. I wouldn't write it as a mixed fraction. I would either leave it as this improper fraction or take a decimal approximation. All right, so those are 3 quick examples. What I'm going to do is advance to the next slide now. And you'll see examples 4 and 5. What I would suggest that you do right now is to pause the video, try those out. I'm going to go through those very quickly, and then you can check your answers when you're done and see if everything worked out properly. All right, so for number 4, I'm going to add 15r to both sides. We're going to get 30r squared plus 15r equals 0. Factor out the greatest common factor, which is going to be 15r. 30r squared divided by 15r is 2r. Positive 15r divided by 15r is 1. Now we'll take each of these factors and set them equal to 0 and solve these equations. So the first one, we're going to get r equals 0 when we divide both sides by 15. Second equation, subtract 1 from both sides, 2r equals negative 1. Divide both sides by 2, we get r equals negative 1/2. So our solutions are r equals 0 or r equals negative 1/2. For number 5, I'm going to add 12p squared to both sides. So we're going to get 12p squared minus 30p equals 0. Again, looking for a greatest common factor to take out of here. So 12 and negative 30 are both divisible by 6. That's their greatest common factor. P squared and p, the greatest common factor is p. So 12p squared divided by 6p is 2p. Negative 30p divided by 6p is negative 5. Again, set each of those factors equal to 0. Applying the zero product property. The equation on the left, 6p equals 0, divide both sides by 6, we get p equals 0. Or on the second one, we're going to add 5 to both sides to get 2p equals 5. Divide both sides by 2, we're going to get p equals 5/2. So again, I'd leave that equation, that answer either as an improper fraction like 5/2 or take a decimal approximation, but I wouldn't write it as a mixed fraction. All right, so one last thing to accomplish before we're done with this video is we want to find the zeros of the function. So let me kind of just break this down for you, how this is similar technique but different than the previous problem. So in this case, if we were to graph, for instance, number 6, f of x equals x squared minus 15x, that graph could potentially intersect the axis 2 times. Could actually intersect it twice, could intersect it once. could intersect it 0 times, okay? But it's in this case, it's going to intersect it twice, and there's a reason why I know that. I'm going to explain that to you in just a second. Now, what I would suggest that you do right now is go to Desmos, graph f of x equals x squared minus 15x, and record the x coordinates of the x-intercepts. And I would do the same thing for number 7. So after you finish graphing f of x for number 6, for number 7, graph f of x equals negative 3x squared plus 27x, and record the x-intercepts, and specifically the x values of the x-intercepts. So I would pause the video, go and do that, then jot down your solutions, and then come back and watch the remainder of this video. All right, so to find the zeros of the function, what we're going to do is we're going to replace f of x with 0. So when we're thinking zeros, graphically, we're thinking x-intercepts. To find the x-intercepts, we're going to basically do what we've been doing. It's just now we have to replace f of x, which is the y-coordinate of an x-intercept. It's always going to be 0 with 0. So I'm going to factor out an x minus 15 equals 0, and then set each factor equal to 0. So we'll get x equals 0 or x equals 15. So if you were to graph this function, it's going to look roughly something like this. This isn't going to be exactly what it looks like. All right, but if you didn't go ahead and graph it, this is what it will look like. Something similar to this. Okay? Now, what you'll find is that one of the x-intercepts will have an x-coordinate of 0. So and then one of the x-intercepts will have an x-coordinate of positive 15. The y-coordinates of the x-intercepts are 0. And that's what we did up here. We set f of x, which is essentially the y-coordinate with an input of x, or the output when you input a value of x. We set that equal to 0, and we solve to find out where the graph crosses the x-axis. Second one, the same deal. Negative 3x squared plus 27x equals 0. Okay, we're trying to find the zeros or the x-intercepts of this function. So in this case, I would factor out a negative 3x, and that's going to give us x minus 9. So negative 3x equals 0, or x minus 9 equals 0. So x equals 0, or x equals 9. So in this case, when you graph it, and again, if you want to explore this on your own, you can go to Desmos, and this is just a really quick, rough graph. Your graph's going to look something like this, and one of the x-intercepts will have an x-coordinate of 0, and a y-coordinate of 0, obviously. And then the other x-intercept is going to have an x-coordinate of 9 and a y-coordinate of 0. All right, so I know that was a lot of information, but now you're going to have an opportunity to go and practice. As always, if you have any questions or concerns, feel free to email me, and I will talk to you guys soon. Have a great day.